We finished ellipses, right? Today we're doing hyperbola. All right. Y'all have a good weekend? So I couldn't understand your response when I walked in. Yes, you all entered your codes into my lab. Okay, I knew you had them. I just didn't know if you had actually entered them into the system. So you've entered them into the system? All right. If you need help with that, somebody in your class can help you. I can help you, whatever. But let's make sure, because I know that today was the last day under the free version. Did it actually cut you off, like as of midnight this morning, or did you still have access today? Or did you even check? Or nothing? Okay. Thanks so much for responding. I really appreciate that, y'all. Okay, so let's go ahead into hyperbolas. Before I get into this, do you guys have any questions about anything that we've done so far? Maybe it's a question from the homework that you worked that was due at midnight last night. Maybe it is a question about submitting bonus questions. Any questions that you have? Going once? Going twice? Okay. So let's go right into hyperbolas. Cecilia, could you turn off the front lights if you would, please? Thank you. So I want you guys to give me what you found on the overview. So as usual for this chapter, and this is the only chapter we're going to do it this way, you've got your overview out, you're referring back to that overview over and over and over and over again, because a lot of what I say comes off the overview, not off the actual notes. None of the other chapters has an overview. Okay, this is the only chapter that does. All right, so let's talk about, first of all, the equations for the hyperbolas, okay? So let's go first of all with the equation on the left. What is the equation for that hyperbola? Okay. Uh-huh. All right, so we've got x minus h squared over a squared minus y minus k squared over b squared is equal to 1. How is the other equation different? What is different? The denominators are different? Yeah, I don't think so. The numerators are different? How are the numerators different? Yeah, so just remember, guys, if you're wearing a mask, I'm totally fine with that. But if you're wearing a mask, you have to be louder because you're speaking to a deaf person. And so I have to be able, I can't read your lips, and I'm fine with that. But you guys speak louder, okay? Yeah, I need to trade the numerators, okay? So I'm going to trade the numerators. The denominators, though, are going to stay put. So we've got then y minus k squared over a squared minus x minus h squared over b squared is equal to 1. We had a little dude for this guy too, didn't we? Just like we had a little dude for the ellipses. What's a little dude for this? What was the embedded question for this section? Because honestly, I don't remember. Perfect. What are the equation similarities between the ellipse and the hyperbola? What's similar? Go ahead. Did you say the same setting?
Setup.
Setup? Okay, and what do you mean by that, Dylan?
Where they have either x minus h or y minus k over a squared or b squared.
Okay. Okay. So that's the same things as that we've got some fractions going on, right? And they look very similar to the ellipse. What else? They equal 1. Good. What else? The denominators. Yeah. Okay, so what's different? The fractions are different? Oh, the subtraction. Yeah, I have subtraction instead of addition. Okay. What else is different from the ellipses? Little dude changes. Good. And I can think of one more thing. Look at the equations themselves. What switches on ellipses? The denominators. What switches on the hyperbolas? The numerators. Okay, so the hyperbolas, my denominators are not trading. A squared is always first, period. A is always first. Can you go back in your mind to ellipses? What is it that determines which one was A versus which one was B? Yeah, the larger one had to be what? A, because A was always on which axis? The major axis. Well, that's also something that's different here. A might be larger than B, but it might not. What are my two axes called for the hyperbolas? Yeah, the transverse axis and the conjugate axis. We don't have a major and a minor anymore because one is not necessarily longer than the other. Transverse axis might be longer than the conjugate axis, but it might not be. Now, nope, I'm going to ask this instead. What are the major values on the transverse axis?
Foci.
How many?
2.
2 foci. What else? 2 vertices. And the center. So these are on the transverse axis, but just because they have our 5 major values doesn't mean it's a longer axis. Okay, it's just the more important axis, even though it might be shorter. Okay, so enough of a intro then to that. Let's just go right on into graphing. Now, before I can get started on example number 9, what has to happen? Got to get standard form. What am I going to do that? Divide by what? Divide by 100. All right, so all 3 terms divided by 100. So I got my equals 1 on the right side, which is what I wanted. What's my first fraction? Over 25. And then? Okay, good. Okay. Where is my center? -9, -6. Let's just go ahead and go put that onto our graph. All right, so, and you can count blocks, be sure to number them so that you'll know what's going on. 2, 4, 6, 8, 9. So it's -9, 2, 4, 6. So there's my center. What is my A value? 5. Where do you get that from? Yeah, A squared is 25, so my A value is 5. And what's my B value? It's 2. All right. So what do I do next? Okay, so let's talk about how do you know, so this is going back to your overview. How do you know if the hyperbola is supposed to open up right and left, or if the hyperbola is supposed to open up and down? How do I know which one to choose? You know, in the ellipses, it all depended on the denominator, didn't it? But that's not the case anymore. So how do I know if a hyperbola opens right left or up down? Say it again. Okay, if x squared or y squared is in the front. Now I'm going to take that a step further, and I'm going to say we're really looking at which fraction is the positive fraction. And the reason I take that a step further is that on that first equation, I could put the y's first with a negative in front of them. So it's not necessarily which one is written first, because I could totally switch those around legally. It's the one that's positive that I care about. The positive fraction tells me how to open up. So when you look at your equation, look at the first equation up here. Which one is the positive fraction, the x fraction or the y fraction? It's the x fraction, so it opens up along the x's. It opens up right and left. But on the second one, it's the y fraction that's positive, so that's going to tell me to open up and down. Okay? So that's how I can tell the difference. So then let's go back to the example that we're working on, right? Which direction is this going to open up? Right, left, or up, down? It's going to open up right, left. Now, here's something that I believe it is not in the overview, and it's not even written in the notes, but you're going to want to write this down, okay? Your A's and your B's will hand you your box. Your A's and your B's will hand you your box. And you're saying, box? What are you talking about? Your A's and your B's will hand you your box. Your box will hand you your asymptotes. Your box will hand you your asymptotes. So your A's and your B's are going to hand you your box. Your box is going to hand you your asymptotes. Your asymptotes will help you draw the hyperbola. Okay, so A's and B's will hand you your box will hand you your asymptotes will help you draw your hyperbola. Okay, now let's put that into practice. Let's see what that means. Because right now it doesn't make a whole lot of sense, okay? And so when you look at the center, I already have the center drawn. Which direction will I go to draw my A's? Right, left, or up, down? Why will I go right, left? Because what's positive? Yeah, my x's are positive. So remember, what is A tied to? This is on your overview. What's A tied to? It is tied to the transverse axis. Very good. What is A? Yeah, it's my distance from the center to the vertices. Okay, so if I'm going to get to A, I got to go right and left that value of A because that's where my vertices are going to be. My vertices have to be right and left because it opens right and left. Okay, so let's go to the right 5. Let's go to the left 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You know what? So far, what does this feel like? What does this feel like drawing? I couldn't, so I don't know if you're telling me the right thing. I just couldn't understand you. Somebody over there said something. But since I can't read mouths, I don't know who is saying anything. What does this feel like so far? I'm totally comfortable with quiet. I can wait. What does it feel like, Juan? Yeah, it feels like an ellipse so far. So far. It'll be different, but it's what it feels like so far. Okay, which direction do I go to get my B's? Up and down. Okay, so we're gonna go up 2 and down 2. Do you see that there is a box that's starting to appear? Like you've got a top and a bottom of a box and a right and a left of a box. Like I said, your A's and your B's are gonna hand you your box. So what I'm gonna do, let's go draw the corners of the box. I could draw the whole entire box, but that starts to get really messy. So I'm just gonna draw the 4 corners of my box. Okay. What did I tell you a few minutes ago? A's and B's hand you your box. Your box hands you your asymptotes. Okay, asymptotes are going to stretch from corner to corner. Asymptotes are going to stretch from corner to corner. Let's go look at the examples that I gave you. You see that I've got my box. By the way, this is actually called a reference rectangle. Okay, so for saying that correctly, that's what that box is a reference rectangle. And you can see that these asymptotes are going through corner to corner on my box. Okay, so that's exactly what I'm going to do then to draw my asymptote here. Let's draw asymptotes from corner to corner. I strongly recommend using a straight edge. It makes your life so much easier. Okay, so I don't have the ability, by the way, you're going, I don't have a straight edge. If you have an ID card, you've got a straight edge. If you've got a piece of paper folded up 4 times, you've got a straight edge. If you have an index card, you've got it. Everybody in here has a straight edge of some sort. Okay. So let's see. I'm gonna just make my color a lighter color. Or you could do a dashed line. Usually I do a dashed line, but my iPad doesn't do straight dashed lines. So I'll just use a lighter color. So there's 1 from corner to corner. And you want to extend those out quite a ways because your hyperbola is not inside the box. Your hyperbola is outside the box. Which direction did we need to go to be able to find our vertices? Up, down, or right, left? Right, left. So we've got our vertices marked, 5 units to the right of the center and 5 to the left. So remember what I told you, A's and B's hand you your box hands you your asymptotes help you to draw your hyperbola. And so what I'm gonna do here is, this is one of my vertices, and I'm gonna draw my hyperbola so that it's getting closer and closer and closer to those asymptotes. Remember that an asymptote is kind of like a fence. You're getting closer and closer and closer and closer to it, but you're not allowed to touch that fence. All right, so we'll just go ahead that, oops, I don't want to do gray. Let me get back to red. So I'm just going to get closer and closer to that fence without touching it. And then I'll do that over on the other side as well. Now, in the directions, I was asked for a few things, and I've done almost everything I needed. I was able to graph it. I was able to give the center. I still need to give the domain and range. So what is my domain? From left to right, where do I begin? Good, from negative infinity, all the way to negative 14. Am I going to use that 14 number? Or am I not using it? I'm using it, but what does that mean? Yeah, give it a bracket. Okay, in union with, where does my domain pick back up again? Negative, negative 4, right? All the way to infinity. What about my range? What is it? Yeah, all real numbers. Bottom to top, I'm using every y value. Okay. So the big thing with hyperbolas, you got to know your a and your b, just like you did with ellipses. But then your a and your b doesn't draw an ellipse. Your a and your b draws a box. Your box draws your asymptotes. Your asymptotes draws your hyperbola. Okay. Any questions on that? Okay. All right. Let's skip number 10 and let's go to number 11. Let me read the directions though. We should be finding an equation. Okay. So we haven't ever done one of these in the hyperbolas, but we've done one of these in every other conic section that we've studied so far. So how would you begin? What would you do? Sketch? I think that's a great idea. So let's figure out where our vertices are. Our vertices are at 0, 5, and 0, -5. And I'm going to put little V's there to remind myself that they are vertices. Now, I haven't even paid attention to the other piece of this, but just drawing that small picture, there are some things that I already know about this particular hyperbola. So tell me some things that I know. It's going to open up and down. Very good. Okay. So I'm going to just draw myself a little, toot, toot. There we go. It's opening up, it's opening down to remind myself. Okay. What else does this picture tell me? Good. The center is at 0, 0. And there's one more thing that I can think of that this picture tells me. Yeah, my A value. What is my A value? My A value is 5. So that also tells me that when I'm ready to write my equation, I'm going to have my A squared value quite easily. Okay, so that's one piece of my equation that I already know. Okay, So that's pretty much all that this picture tells you. Keep reading the rest of what you have given to you. So my hyperbola passes through the coordinate 310. What did we do every other time when this happens? Yeah, plug it in for what? Exactly. We're going to plug it in for x and y. So that 310 we're going to use as our x and our y. Okay. So let's go ahead and write a preliminary equation. This is not our final answer equation. It's just a preliminary equation. So we have fraction minus fraction equals 1. I already mentioned that we would know what my a squared is, but where do I put a squared for the hyperbola equation? It's got to be in the first fraction where? On the bottom. So I'm going to go ahead and put my 25 down there. What values are going to go on the top of the first fraction? Yeah, so what am I going to write down? Yep, 10 minus 0 quantity squared, right? And what's on top of the second fraction? 3 minus 0. That's my x minus h quantity squared. And what goes down on the bottom of my second fraction? Yeah, b squared. And the nice thing is that the only unknown here is my b, so I can solve for that one unknown, and that's going to be totally fine. Okay, so let's clean some things up. How does the first fraction simplify? Yeah, it just simplifies to a 4. Minus, how does my second fraction simplify? 9 over b squared. Okay, and then what? What do I, again, the goal, we know the goal is to get b alone, but how do I go about doing that? Okay, so I'm hearing two different things, I think. I'm hearing subtract 1, and I'm also hearing subtract 4. Okay. Either one of those is correct. Ultimately, you want your b to be alone, right? And do you see how the b fraction is a negative fraction? So me personally, I think what I would do is I would take that whole entire b fraction over to the right side so that it's positive, and I would take the 1 over to the left side and subtract the 1. That's not the only option that you have. It's an option, okay? It's a single option that you've got. All right, so 4 minus 1 then is 3 is equal to 9 over b squared. And then what? Multiply by 9? Divide by 9? Okay, let's stop right there for a minute, because this is actually a very common place where students go wrong because you forget what to do from other classes that you've had. If you divide by 9 on both sides, don't write this down because I'm going to need to erase it. If you divide by 9, does this leave you with a b squared? No, it does not. And you want b squared alone. If you divided by 9 on both sides, what would that leave you with over there on the right side? It wouldn't leave you with a b squared. It would leave you with, no, the other way. It would be 1 over b squared. It would be a 1 over b. You guys remember that if you're going to divide fractions, you invert and multiply, right? Okay, so let's see how this is a 9 over 1. If you multiply by the reciprocal, this is going to be a 1 over 9, right? Your 9s are going to cancel. You're going to be left with a 1 over a b squared. You're not going to be left with a b squared. Okay, so that is very, very, very common for students to try to divide by 9 on both sides, but then magically tell me you're left with a b squared, but you're not. Okay, so you gotta be on guard for that. Just because it's common doesn't make it right. Okay, what's the better option? Multiply by b squared on both sides. Multiply by b squared on both sides. That's going to give you 3b squared is equal to 9, and then you can divide on both sides by 3. So that'll be b squared equals 3. Okay, now, what were my directions on this question? Find an equation. What are the 4 things I need to have to be able to write an equation? HK, A and B. I got all 4 of those, so I'm ready to write my equation. Okay, so we've got fraction minus fraction equals 1. What goes on top of the first fraction? Why what? It's not just a y squared. It's y minus 0 squared, but then you would end up cleaning that up to a y squared. What goes on top of the second fraction? X squared. What goes on bottom of the first fraction? 25. And what goes on bottom of the second fraction? Okay, is it 3 or is it 9? Why is it 3? B squared is in the equation, and that guy says up there that B squared is 3. Okay? All right. Let's see what you guys can do with number 12. Okay? Try number 12. I don't mind if you talk about it amongst yourselves. Try number 12. See what you can do. Just because think of it like this. So I'm reading your test. I don't have access to your mind, but I do have access to what you write on paper. So if there's something that I can't see, it's hard for me to get partial credit for it. And I love partial credit. All right, let's take a look. So as I was walking around, I was making sure that everybody was sketching something first, so that you can, it's visual to you. And one of the things that I mentioned as I went along, the less you put on paper, the less I can give partial credit, right? So on your test, and by the way, your test is coming up, right? It's next week, I believe. And so one of the things that students will do is they do all this work in their minds. And if they get it right, that's great. But what you need to know on my lab, if you don't show me work, you ready for this? I don't give you credit. If you don't show me work, I don't give you credit. Okay? So like occasionally there'll be some multiple choice questions. Well, I know you can guess eeny, meeny, miny, mo, right? And you might guess correctly, but I will not give you the credit for the correct answer unless your work backs that up, okay? So this is not a dartboard where you just throw the dart and hope you hit the right one. Ooh, I got the points. You can get the right answer and still get the problem wrong. Are you hearing me on that? Okay, so you will be provided with paper to show work. If that work does not back up your answer, if that work does not support your answer, you will not get credit. You will not, okay? And then on the other side of that, I love, 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 love giving partial credit. But if there's nothing written there, there's nothing I can give credit for, okay? So give me some work so that I can give you partial credit. Like let's say you get the answer wrong, but you did most of the work correctly. You just did something crazy, you know, like 2 + 3 is 6. You know, we've all made a mistake like that before. And so I can go back and give you partial credit on the stuff you did right, even though you got the wrong answer, if you have work shown. If you don't, there's nothing I can give. Okay. All right. So what does this picture tell me? It tells me multiple things. What does it tell me? Okay. I know it's going to be an up and down hyperbola because if this is my vertex, it's got to be opening up and down like that. I only see half of it, but I know it's going to open up and down. What else does this picture tell me? A is what? And how do you get that? Yeah, from the vertex to the center, that's 6 units. From -7 to -1, that's 6 units away. So my A value then is going to be 6. What else does this picture tell me? My C value, what's my C value? And how do you get 9? Yeah, I'm getting 10. How do you get 10? From the center to the focus. So you've got 7 units below the x-axis and you have 3 more units above the x-axis. 7 and 3 gives you a total of 10. Okay, great. I'm still supposed to find an equation. What are the 4 things I gotta have to write my equation? HK, A and B. What am I missing? I'm missing my B value. Okay. How am I gonna get my B value? Yeah, little dude. Right? Do you remember me saying on the ellipses that the only time you're going to work with little dude is when you're working with a focus? Oh, guess what? We're working with a focus. Okay? So the fact that I'm working with a focus tells me you're probably going to need little dude here. Little dude, A squared plus B squared equals C squared. I know A squared, so that's 36. C squared is 100. So you want to subtract 36 on both sides, and I believe that's going to give you 64. Okay. Okay, I've got everything I need then to write my equation. I have HK, I have A and B. So then we'll go to the side. It's going to be fraction minus fraction equals 1. A squared has to go underneath the first guy. So that's going to be what? 36. B squared has to go under the second guy. for hyperbolas. Who goes up on top, X's or Y's? How come? Because it's opening up and down, so it's my Y fraction that has to be the positive fraction. So what's going to go up on top then? Y plus 7 quantity squared. And then what's going to go down on the bottom? I mean, sorry, what's going to go on the top of the other fraction? X minus 9 quantity squared. Okay, and there is my equation. Any questions? I'm sorry, I'm so boring, Madison. I pulled up the schedule for a minute because I wanted to point out some things. I just talked about the test, but I wanted to point out a couple other things. I do want to get to section 8.3 today, which is a breeze section, but I've left myself a little bit of time. I would fully expect that on Wednesday, we're going to be able to have some time to get into my lab, and we're going to be able to work through some things on my lab together, kind of like a lab day in class. So you can either use the computer that's in front of you, or you can use the computer that you've been provided by the school. Either one, I don't care. But you'll definitely want a device to work on Wednesday, because we'll have time to have a lab day on Wednesday. Another comment is that you notice that the test is a week from Wednesday. That will be taken on the computer. Okay, so again, I don't really care. Those of you who are sitting at a computer desk, if you use the computer in front of you, that's fine. Or if you want to use your device computer, I'm fine with that too. But either way, you will be taking your test on my lab, okay? The third thing I want to mention is you'll notice that on Wednesday, this coming Wednesday, I'm going to be talking about section 8.4, but I'm also going to be talking about the unit circle. So I wanted to take just a minute to prep you for what you're going to be doing here. I actually will not be teaching you the unit circle on Wednesday. Hear me and hear me well, okay? The unit circle will be the most important thing you learn this entire semester in this class. Starting on Wednesday, you will use the unit circle almost every single day of class. It will be on every test, and when I say it'll be on every test, I'm not going to just like put a blank unit circle and say, here, fill this in for points. From every test, you will need to understand and know the unit circle well. This is a big deal. It's kind of like entering 6th grade math, never having learned addition. That would be absolutely horrible, right? Let me tell you, and this is what I tell my college students, if you don't learn the unit circle well, drop my class, you will not pass. It's that important. It is that important. It is the foundation for every single thing we do for the rest of the semester, chapter 9, chapter 10, chapter 11. You think, oh, she's just trying to scare us. I am, because every bit of what I'm saying is absolutely the truth. Okay, this is a big deal. Now, you say, wait a second, Ms. Roberts, you just said that you're not teaching it to us. So, you're not going to teach us the most important thing the entire semester? What kind of teacher are you? Believe me, I get that all the time. I've placed these on videos. They're the most important videos you're going to watch. The most important videos. So, well, why won't you teach us in class? Because in class, you get it once. On a video, you can get it as many times as you need it. If you need to watch it once and you got it, fine. If you need to watch it 10 times before you have it, do it. You're not going to have that opportunity with me. I'm not going to stand up here and explain something 10 times just because one person doesn't get it quite yet. I put this on video because it's so important. Okay? So those videos, and let me tell you, let me just say this right now. If you're not watching my videos, you're not gonna pass my class. But those videos are more important than any other video that we have. Okay? And to follow that up, for section 9.3, which is, it's down the road, I'm not worried about that yet. 9.3 has another set of unit circle videos where I add to the first set. Those are also the most important. Any video that deals with the unit circle is the most important video I'm going to give you all semester long. Okay? So that's kind of my little warning. I'm telling you, if you're not going to learn that unit circle well, and I mean, you should know it really well. Like if I were you, I probably would like print off, I don't know, 5 or 6 of those blank unit circles that I provided just to see if you can fill them out without looking at it again. But if you're not gonna learn that, drop my class. And if you're not allowed to drop my class, then you better learn the unit circle. Okay, it's huge. It's huge. Big deal, big deal, okay? All right, so I'm about to leave the calendar. Do you guys have any questions before I just get rid of the calendar and go back to section 8.2? Anything? Okay. If you're wondering, those 2 orange guys, I did that because I traded 2 sections and I just kind of wanted to show you, I'm not going in order. Okay, so that's the only reason that they're orange. Okay, so back to section 8.2 here. What is wrong with number 13? It's not in standard form. Okay, so the first thing that I'm supposed to do is to get the standard equation, then I'm supposed to get the center and the vertices, and then I'm supposed to graph. So the big deal here is let's get that standard equation. What do I use to get a standard equation on something that looks like this? Completing the square. Completing the square. Okay, so then what will I do first? Okay, and so for the x's, I'm going to be factoring out. All right, so let's do that first. When I factor a 4 out of all the x's, what are my leftovers? X squared plus 4x, and don't forget to leave yourself some space to complete the square. If this isn't comfortable to you by now, you haven't been practicing enough. This should be comfortable to you by now. All right, what am I factoring out of the y's? Negative, and that's a really big deal, negative 9. Okay, what am I left with when I factor out a negative 9? Y squared, what was that second piece? Minus, why is it minus? Because you factored out a negative. Okay, so minus, what was the rest? I didn't listen. 2y. Don't forget to leave some space to complete the square. And my 29 constant, that's already over on the other side, so I don't need to do anything with that. Just leave it over there. All right, what's next in my completing the square steps? Say that again? Okay, yeah, so let's take half and square. Take half and square, okay? What's my first b value? 4, take half. 2, square it. 4, so I'm gonna add 4, but its value isn't really a 4. What is its value? And how are you getting 16? That 4 out in front, remember those 2 guys are so really what I just did is I added a 16 on the left. And if I added a 16 on the left, I also have to add a 16 on the right. Okay. So now let's go to the y's. What's my b value? Negative 2. Take half. Negative 1. Square it. 1. What will I do with that? Yeah, so I'm on the inside of the bracket, I'm going to add the 1. But truly, it's not a 1. What is its value? It's a negative 9. So if I If I put a -9 on the left, I must put a -9 on the right. Okay, so let's clean that up then. My constants, if we combine our like terms, 36. Okay. My next step is to factor the trinomials. So I'm going to have 4 times, what is that trinomial? Factored. X plus 2. Okay. What do I keep writing? -9 times y minus 1 quantity squared. Okay, so my standard equation is starting to emerge. What do I need to do? Yeah, let's divide each of the 3 terms by 36. So my first simplified fraction will be minus over 4 is equal to 1. All right, good. So now I have my standard equation. I can actually begin the question. And the first part of the question was what's the center, but another part of the question was go graph. Okay, so let's do this simultaneously. Where is my center? -2, +1. So let's go over to my graph here. Okay, -2, 1. There's my center. All right. I graphed one of these. It was the very first example I worked on today. Where do I go from here to graph a hyperbola? Which way does it open? Okay, that's great. What way does this one open? Has to open right and left because x's are positive. Okay. What else do I need to do to be able to graph? I need A and B, don't I? What does A and B hand me? A box. Okay, so let's go ahead. What is my A value? 3. What's my B value? 2. So let's go back to our graph. Can you remind me, because I forget, A value, is that going to go right and left or is it going to go up and down? Right and left, because the hyperbola opens right and left. Okay, and so what value was A again? So let's go to the right 3 and let's go to the left 3. Okay, so the B value is going to go up and down. What was the B value? 2. So let's go up 2 and down 2. So I can see the top, the bottom, the right and the left of my box. I'm just going to throw in some corners. Okay, so A's and B's hand you your box. Then what? What does your box hand you? Your asymptotes. Okay, so then let's draw our asymptotes from corner to corner. I'm using colors here. I don't have a problem if you use colors, even on the test. If that's something that helps you out, go for it. Okay, so your box hands you your asymptotes, and then your asymptotes does what? Yeah, it hands you your hyperbola. Can you remind me, was this supposed to be up, down, or right, left? Because honestly, I'm looking at that and I don't know according to that picture which one it is. It's got to be right, left. So keep reminding yourself of that. So you have your vertices marked. So use your asymptotes there as fences. Go back up and check those directions because I think there's one more thing I'm supposed to do. Yeah, I need to tell what the vertices are. I could have done that before I graphed, but it was actually easier to do it after I graphed. Okay, but it doesn't matter. I won't know which one you've done. So where are my vertices? So -5, what was the second piece I just couldn't understand? Okay, and 1, 1. All right, any questions on that? Anything at all? Okay, you guys want to try to get a standard equation on your own? Complete the square. Complete the square. How did we do on the standard equation? Did you get the same thing I got? Check all your signs. Same thing? Okay. And I was asked for the standard equation, so I got that part. I was also asked for the center. This part's easy. So where's the center? -1, 2. Okay. Which direction do I have to go to find my vertices? To the right and to the left. How far? Say that again. Yeah, I got to go the square root of 7 to the right and the square root of 7 to the left. Okay, so we'll see if you guys remember how we did this earlier last week. So which value of my center is changing, the x piece or the y piece? It's the x piece. So I already know that my vertex is going to have a y value of 2. The y value is not changing. Okay, because I'm not doing any up and down here. I'm just going to go to the right and to the left. So how do I write? I'm starting at -1, but I got to go right root 7 and left root 7. How do I write that? So you're just going to write plus or minus the square root of 7, and that's going to be your x value? Oh, yeah, you forgot about that part. Okay. So let's scoot all that over. What was it? Yeah, that's your starting place. So you're starting at -1, and you got to go to the right root 7 or the left root 7. And 2 then is my y value. You can write those separately if you want to, or you can write them together. That doesn't bother me. And that was the only things that I was asked for on this question. Okay. Any other questions before we go to the next section? Good. Okay, so let's head into section 8.3. This is a pretty quick section, which is why I left it for the very end of class period. And it's also kind of a recap on everything you've done so far. Okay. Now, before I do this, I want to remind myself of my standard equations, okay? So you got to go back in your minds. What was the standard equation for circles? See if you can give that to me without looking. If you have to look, that's fine, but try to tax your brain a little bit. What was the standard equation for circles? Mm-hmm. And circles only had one equation. Okay. What was the equation for parabolas? You can go back and look. Good. I'm glad I was back here. Otherwise, I wouldn't have heard a thing you said. You're right. Now, there were 2 of these, weren't there? So I'm not going to write the other one. You should be familiar enough with this by now that you can look at this one and automatically know what the other one is without it being written down. Okay. How about my ellipse standard equation? Good job. Okay. And then our newest one, the hyperbola or the hyperbola. Same thing with a minus. Well said. X minus h squared over a squared. And again, I didn't write the second version of each of these. You should be well familiar enough with these by now to know how to get the second equation, especially if you can see the first equation. Now, what you see, my handwriting right there, I have provided that on the test as a formula sheet, okay? I did not provide the second version of the equation, okay? And I don't remember if I provided little dude, but for now, let's say I didn't because I can't remember. Okay, let's just say that I didn't provide little dude. But little dude's pretty easy to remember. Don't they both look like the Pythagorean theorem, except that one's a minus and one's a plus? The way I remember is little dude for the ellipse is the one with a minus. It doesn't match its standard equation, and little dude for the hyperbola is a plus. So like they're traded, okay? So their signs are not matching on there. So you will need to know what little dude is. But I have provided those four as a formula sheet for you for your test, okay? Now, let's take a look then at this particular set of 4 examples. And I want to point out some things that my lab does that's going to be different on your test. Okay, so you need to pay attention because I don't want you getting to your test and going, this is different. Yes, she's telling you it's different, okay? All right, so notice that the directions say, tell whether the following is a circle, a parabola, an ellipse, or a hyperbola. Okay, no problem. And give a short explanation, okay? Now, here's a lot of times what my lab will do. My lab will make it a multiple choice question. Right? And it'll say this equation is a parabola because, and then it'll give a short explanation that you have to read. Okay? Or maybe it'll say this equation is the equation for a circle because, and it'll give you an explanation. On your test, it's not going to be multiple choice. Okay? Or, well, let me rephrase that. It'll be multiple choice. Okay? The first part will be A, this is a parabola, B, this is a circle, C, this is an ellipse, D, this is a hyperbola. So yeah, that part is a multiple choice. But then the directions will say something like, go to your show work page and write down your explanation. Okay, so you'll actually have to write an explanation for me. It's not going to be part of the multiple choice. That will be in like, it'll be probably a multiple choice for your practice test, which I'm still working on. It'll probably be a multiple choice for your homework, but it's not going to be a multiple choice for the explanations on your test. I want to know that you can give me a good explanation, okay? And I'm going to model that for you right here. Okay, so you're looking at your 4 equations, and you're looking at these 4 examples. Let me see if I can turn it so that I can enlarge it just a bit. Now, I don't really care right now about going in order. Okay. So just look at the 4 equations. Does one of those pop out as either a circle, an ellipse, a hyperbola, or whatever I haven't said yet? What's that? What's number 1? Why do you feel like number 1 is a parabola? Nicely said. Okay, so I'm guessing you can't hear her because I had to go get non-socially distanced to hear her. No, I'm just kidding. We were still socially distanced. It was okay. What she said that number 1 has to be a parabola because only one variable has a square in it. The other variable doesn't have a square. So do you see how on our 4 equations, all 4 equations, 3 of the 4 equations have double squares. X's are squared and Y's are squared. Parabolas are the only one that has a single square, right? So then when I look at number 1, I don't even have to complete the square. I don't have to clean it up. I don't have to get a standard equation. I can just say, hey, Ms. Roberts, this is a parabola. Why? Because only y is squared. Only the y is squared. And again, when I put you back to the directions, it says just give a short explanation. You don't have to go through a whole bunch of mathematical work to give me this explanation. Okay, this is good enough. Okay, so 3 to go. Does one of the other equations pop out as a, oh, this has to be such and such because why would you say, Leah, that the bottom one is a hyperbola? What makes you say that? Oh, so Leah says that on example number 4, my x squared term is negative. Now, what's the only conic section that has a negative on one of the squared terms? The hyperbola. Come back up to your 4 equations. For my circle, both squared terms are positive. Parabola only has 1 squared term, so I'm not looking at that one. But for my ellipse, both squared terms are positive. It's only the hyperbola that one of the squared terms is negative. All right, so for example 4, we're going to say it's a hyperbola. Why? Because the x squared term is negative. The x squared term is negative. Guys, that's a short explanation and it's sufficient. It tells me exactly what I need to know. Okay? The x squared term is negative. All right, 2 down, 2 to go. What do you think? Oh, it's Savannah, right?
Yeah, number 2 is a circle because it equals 36.
Number 2 is a circle because it equals 36. Savannah, I think that's a very, very interesting comment, and it makes total sense to me. I'm going to blow your mind for a minute, though. Okay? Let's go back to the circle notes for just a minute. You don't have to pull yours out unless you just want to. This is a circle equation, right? Let's pretend that we had never looked at circles before. Let's pretend that we had only ever studied parabolas, ellipses, and hyperbolas. If we had only ever studied those 3, I would look at that equation and say it's not in standard form. And what would I do to make it in standard form? I would divide everything by 25, wouldn't I? Okay, and that would become x minus 5 squared over 25 plus y plus 1 squared over 25 is equal to 1. So are you telling me that the circle equation can actually look like an ellipse equation? Really? Yeah, it can. Let's go back up to that standard equation. Couldn't I just divide all 3 terms by my r squared, whatever my r squared is? Absolutely. Well, what am I supposed to do with that then? That's gonna have to wait till Wednesday. Remind me that I didn't finish those last 2, but I want you to be thinking about that. actually thinking about circles and ellipses, start thinking about what's different and what's the same about a circle and an ellipse. And we'll continue this discussion on Wednesday.
You know,